As we are reviewing motion, the position, velocity, and acceleration functions, here are the important terms to remember and that we will refer to in this video. So the graph shows the position function of a radio-controlled model car. Answer these questions and explain. It's extremely important to know which function you're looking at. Are you looking at the position function, the velocity function, or the acceleration? They told us we're looking at the position function, which is in general what we are most used to. Knowing that it's the position function tells us some very important things, such as this axis is labeled in time. Your y-axis, of course, is the position of the remote control car. When the position is increasing, the distance it is from where it started is getting greater, and then as it decreases, it's coming back to where it started. So remember that your positive slopes indicate upward or rightward movement, and your negative slopes indicate leftward or downward movement. Was the car going faster at A or B? So faster is asking us about speed. Speed is the absolute value of velocity. Okay, great, but they didn't give me the velocity function. They gave me the position function. So how does velocity relate to the position function? Okay, well, the velocity function is the derivative of the position function. What is the derivative at A and B, and when is the absolute value of that derivative the greatest? So the derivative at A appears to be this. The derivative at B appears to be steeper. So the derivative at B is greater, meaning the velocity at point B is greater, meaning the speed at point B is greater than point A. Well, we chose B, and then I described y, saying the derivative or slope at B is steepest. So I described in context of the graph, and then I described it, the speed or absolute value of the velocity of the model car is greatest. Then I described it in context of the problem. It's so important that your descriptions are comprehensive. I would rather you write too much than not enough, because that would be a shame. So please, when you are justifying these answers, I will be very strict on what explanation is good enough. So make sure you are describing it in context of the graph, but also interpreting it in context of the problem. When was the car stopped? Stopping the car would involve a speed of nothing, right? If your car is in park, you're going 0 miles per hour. When the speed is 0, we have no motion. When the velocity is 0, we have no motion. So we're looking for when the velocity or the derivative of the position function is 0. Where is that slope? 0. Okay, the slope is 0 between the points C and D. So the car is stopped between the times at C and D because the velocity is 0. At which point was the car's velocity the greatest? So when's the velocity the greatest? That is the maximum of the velocity function. But how does that relate to the position function? Well, that is the greatest positive slope of the position function. I already know the slope of B is steeper than the slope of A, and because they're both positive, then the slope at B is greater. And then it becomes less at C, and then it starts to turn negative. So the greatest positive slope is at point B, Therefore, the car's velocity is greatest at B. I see we said greatest here. It's greatest out of A or B. So I guess it would have been better to say greater because we were just comparing A and B. But it just so happens that B is the greatest velocity. But at which point was the car's speed the greatest? So speed is talking about the max of absolute value velocity. We don't care where the object is going, if it's going rightward or leftward or upward or downward. We only care about its true speed. How fast is it going? So we want to find the maximum of the absolute value of v of t. How does that look graphically? That is asking for where is the slope of s of t the steepest. So not caring about it being positive or negative, looking for it being the steepest. Where is our slope the steepest? This one, not super steep. E looks to be pretty steep. F seems to be rounding back out. So it looks like E has the very steepest slope. And even though the slope is negative, it's going to be the greatest speed because the negative tells me the direction. The negative does not affect the speed. At point E, the slope is steepest. Therefore, the car's speed is greatest at point E. In context of the graph, slope is steepest. In context of the problem, car's speed is greatest. Vertical motion. So suppose your position function is given here, and it gives the position in feet above the ground for a ball thrown into the air from the top of a cliff in time seconds. Here's my beautiful drawing of somebody throwing a ball up into the air over the cliff. Find the initial velocity. Initial velocity is the velocity after how many seconds? It's the initial one, so after 0 seconds have gone by. The position function we need to derive in order to get our velocity function. Negative 32t plus 48 is the velocity function, and now I want to know the velocity at 0. So that would be 48. Velocity is measured in units over time, so feet per second. At what time does the ball hit the ground? The ball hits the ground when the position of the ball is 0 feet above the ground, when it literally hits the ground. So I want to know when s of t equals 0. We can factor out a negative 16. Divide both sides by negative 16 and you'll be rid of your coefficient. So this would be t minus 5, t plus 2. So the times at which the ball could possibly hit the ground would be at positive 5 seconds or would be at negative 2 seconds. But this is a real life problem, right? You don't have negative time. You start at time 0. So this is not an option. So when does the ball hit the ground? At 5 seconds. At what time does the ball reach its maximum height? We know that the position function is a parabola. We know from our picture it's a parabola. We know the maximum height of a downward opening parabola would be your vertex. And they want to know at what time. Time is the x value. So basically they want the x value of the vertex. That will tell me when you have reached your maximum height. The x value of the vertex of a parabola is negative b over 2a. That's when we're in standard form, and that's what position function is usually given in. Negative b over 2a is what I'm looking for. And our variable is t, so t equals negative 48 over 2 times negative 16, which does reduce to 3 halves. and that is a time. So after 3/2 seconds, or you could say after 1.5 seconds, that is when we do end up reaching that maximum height.